Is time travel possible? Could we journey back to see dinosaurs? Or perhaps witness the far distant future? Humans have always possessed this dream. We dream of effortlessly skipping through time, much like turning the pages in a storybook. But is this merely a fanciful dream, or could it one day become our reality? Time travel at its core means moving. It means moving quite differently through time. Not just steadily forward 1 second per second, it implies the ability to jump far ahead, or, even more astonishingly, to go back. To revisit moments that have already passed. This is truly a profound and big idea. A very big, chakra wall altering idea indeed. You see, we all travel in time. Constantly. We are doing it this very moment, every day. We journey consistently towards the future, always it seems at the same steady speed. 1 minute inevitably follows the previous one. This is our normal everyday experience of time. But is this normal the entirety of what exists? Science, in its curiosity, loves to ask what if. Time often feels like a vast, flowing river, a current moving inexorably in one direction. But what if time is more complex than that? What if it possesses the ability to bend, or perhaps even to have hidden shortcuts? Our universe is an immense and wondrous place. It is filled with many strange cosmic wonders. Time itself just might be one of them. Then a truly brilliant mind emerged on our world. Albert Einstein fundamentally changed our perceptions. He gifted us with revolutionary new ideas. These were groundbreaking ideas about space and time. He proposed that they are intrinsically connected, woven together like a giant cosmic fabric. He named this interwoven continuum space-time. This single concept was utterly revolutionary for physics. Einstein's first profoundly big idea was this. It is a theory called special relativity. This theory states that your speed changes time. If you happen to move very, very fast, almost unimaginably, incredibly fast near light speed, time itself would actually slow down for you when compared to someone who is stationary. So in a way, future travel is indeed possible. Then Einstein presented his general relativity. This is Einstein's profound theory of gravity. It tells us that gravity also bends time. Very strong gravity makes time pass slower. Near a supermassive star, for example, or even more dramatically, near a black hole. Time flows at a different rate in such places. Gravity, in essence, warps the fabric of space-time itself. So, our brave astronauts actually experience this. They travel at high speeds while in orbit. Because of this, time passes slightly slower for them. When they finally return to our Earth, they are a tiny, almost imperceptible bit younger than if they had remained grounded on the planet. This, in a small way, is real time travel. It is travel to the very, very near future. But what about traveling back to the past, or what about making truly enormous leaps forward? Some fascinating theories suggest cosmic tunnels exist. These hypothetical passages are called wormholes. Imagine you could fold the fabric of space-time. Much like you might fold a simple piece of paper, a tunnel could then directly connect two distant points. This would be an incredible shortcut through the cosmos. These theoretical wormholes are truly fascinating objects. They might possess the ability to link distant stars, or even more incredibly, connect different galaxies. But what about their connection to time itself? Some highly speculative theories suggest yes, it's possible. A wormhole could potentially link different points in time, perhaps with one end anchored in our past, and the other opening into our immediate present. Now imagine stepping into one open end of such a fantastical space-time wormhole. You could, in theory, emerge somewhere else entirely, and also, quite possibly, someone else entirely. Perhaps you would find yourself in ancient Rome, or standing on Earth 1,000,000 years from now. This is the ultimate, captivating dream of time travel. The concept of the ultimate personal time machine. However, these wormholes are exceptionally tricky things. We have, as of yet, never actually seen one. They remain purely theoretical mathematical constructs. They might also be incredibly unstable by nature, perhaps collapsing in the blink of an eye. They might require something called exotic matter to stay open. This is stuff with truly weird, unknown properties. We do not even know if such matter can exist. Traveling into the distant past is incredibly complex. It unfortunately creates a great many logical problems. These challenging problems are known as paradoxes. Let us consider the famous grandfather paradox. What if you managed to travel back in time, and then prevented your own grandparents from meeting? If so, then you would never have been born. But then, who was it that went back in time? There are, of course, other paradoxes to consider too. such as the perplexing bootstrap paradox, for example. This describes information or an object with no origin. These logical puzzles make past travel seem messy. Some scientists think paradoxes might actually prevent it. It's possible the universe has fundamental, unbreakable rules, specific rules designed to protect its own history. We simply just don't know what those rules are yet. Another truly huge hurdle is the need for energy. Bending space-time to our will requires immense power, an almost unbelievable astronomical amount of it, in fact, to create and stabilize a wormhole, for instance, or to accelerate a craft to near light speed. We are talking about harnessing star-level energy sources. This is currently far, far beyond our technological reach. Our present-day technology is simply not there yet. So after all this, is time travel actually fact? Or does it remain purely in the realm of fiction? For now, it is overwhelmingly in the realm of fiction. Traveling to the future, just a tiny bit, is real. We know this thanks to Einstein's brilliant insights. But travel to the distant past, or big leaps forward? That exciting possibility remains in stories, in our dreams. The vast cosmos still holds so many of its secrets.